Kolmogorov-Arnold networks became somehow very much in fashion at some point, and they were supposed to be the replacement of the standard deep learning multi-layer perceptron networks. Somehow they are based on the fact that they can have, for instance, multi-layer perceptron networks. They have fixed activation functions, while these fixed activation functions could be learnable too, and also they can be cheaper because, for instance, this representation theorem, what it says is that any n-dimensional function can be represented as a nested or hierarchical evaluation of many very simple functions, one-dimensional functions. So for each one of the components, we apply a relatively simple function, and this simple function is giving you a scalar, and then these scalars you have to add many scalars of this kind, and each one of these phi, small phi, capital Phi, they can be learned. And learned, for instance, we will see later that we can represent them with B-splines, for instance, and then all you have to do is to learn the coefficients of those B-splines. So here we have a comparison between the multi-layer perceptron and the Kolmogorov-Arnold network. So here is the formula for the multi-layer perceptron. Here is the formula for the Kolmogorov-Arnold, and we already know the two of them. So somehow a graphical representation of that is that we can learn the weights. From the input to the output, and then the activation functions are all the time the same. So this is fixed, and then it produces an output. So here we have some functions to learn. These are this phi, small phi, and then we have the capital Phi that is here, that are somehow the activation functions that are also learned. And if we have multiple layers, so what we have is that we have a linear combination of the input vectors that is learnable, and then the activation is not, and then the linear part is again learnable, the activation is not, and then the combination of this one that is learnable. So in these Kolmogorov-Arnold networks, everything is learnable. So we have this layer is learnable, with including the activation function, and this one and this one. So everything is non-linear and learnable. So it is more general than the multi-layer perceptron, but somehow they have not taken over the multi-layer perceptron. So somehow either people is used to this, or they are useful enough, and there might be extra complexities related to the convergence of this kind of networks. And here we have an example of how these non-linear activation functions can be learned. So they can be learned, you can represent them as a B-spline representation, and then all you have to learn is the weights of those small basis functions. And even these you can take advantage of the properties of the B-splines, and you can make these functions even more precise by taking the smaller basis functions that you can initialize with the coefficients that you learned from the previous analysis. This would be all for the Kolmogorov-Arnold. See you in the next one.